Hello and welcome. My name is Victor Lopez, and in this video I'm going to continue building the first deck of Python cards. Python cards, for those who don't know, is this project I'm working on that aims to teach you Python via spaced repetition. Spaced repetition is this way of learning in which you have some flashcards with very small questions that you review daily, and the ones that you learn more quickly are shown to you at longer intervals of time, and the ones that you forget more easily are shown to you more often. It's kind of an optimal way of learning. Python cards is this project, and it includes this website that you have here. Here you have a demo which you will review each card, show the answer, and then give feedback on how easy you remembered it, either good or hard or again or easy. And now I'm building the first deck of cards for this project. It is pathlib in depth. Pathlib is this library for managing file paths and files in Python. And this is the fourth video I'm recording. So in the last 3 videos, we created this long set of cards. These are just markdown files where we have the front and the back of the card, the question and the answer, let's say. And then when we finish with the cards that we have remaining, I will create an import script that will translate all of this text, this markdown file, into actual cards into the project. You can visit Python.cards and join the waitlist in case you're interested. So last day we left it here. We were going through the documentation, so we were in the exists method, and these I think are going to be more or less straightforward cards to create. I also separated them between important, somewhat important, and not so important. So I'm going to, for example, the expand user, I kept it in not so important, right? So sorry, in somewhat important. So let's go through this list and get going. So pathlib, sorry, I'm using second heading, exists. Right? How can you check if a file exists? I would prefer not to use the word exists, but honestly, I think it's the most normal word to use. So we would have an import, right, from pathlib, import path, and then we would do path file.txt, for example, dot exists. These tildes hide the code. You can see in this example here, you see that this code is blocked with a kind of a pattern. This is an SVG pattern, in fact. So this, I have created a kind of a visualizer, a filter in Django that will generate these SVG patterns and put them on top of the code when the code has these tilde characters. So does it exist? And this returns true or false. Using path dot exists. Okay, so could we add some more information about this? We could have a second question, like pathlib exists directory. So you could have this question, right? What is the output of the following code if /etc is a directory? So we could have the same thing here. The question is, does it exist if it's a directory and not a file? etc. And of course it's true. So the output is true because path.exists is true both for files and directories. Okay, so we have exists. Wait, I don't like this. Let me cut this thing and put it here. So we already manage exists. We have this follow symlinks. All of this. This follow symlinks was added in 3.12. Follow symlinks true. I think it was added to many places, right? Let's find the first appearance of this follow symlinks. Okay, this was added in 3.10. So yeah, follow symlinks. We could see how many files the stat has, exists has. Doesn't matter. We're going to have a separate question later on, probably about follow symlinks. It's not that important, and it didn't exist for many years. So let's go with the next one, which is there. So is there. Or a symbolic link pointing to a directory. False if it points to another kind of file. This is important. The part of symbolic link that we also have to create a question for, a card for. So pathlib is there, and then we will create pathlib is there symlink. So how can you check if a file is if a path points to a directory? And this is the kind of thing that you might forget. It could be is it directory? Is it directory? So from pathlib import path, and then we say path /etc dot is there true. So path dot is there. Sorry. Returns true if the path points to a directory or to a symbolic link pointing to a directory. Okay, what if the file does not exist? So, not exist. What is the output of the following command if the path if /home /non-existing user of slash, or what path could I create here that is short and /home, or let's say /bin/ I don't know, RG. does not exist. So here we have bin.rg. Oh, but bin.rg, let's etc nginx. This makes more sense. It's a directory. Do you have configuration for nginx or not? So what happens is that it returns false. So path, for example, path whatever dot is there, because it is a directory. No. So false if the path does not exist. Okay, so that's the behavior of isDir, right? False is also returned if the path doesn't exist or is a broken sibling. Other errors, such as permission errors, are propagated. Okay. What does that mean? What does that mean? Let me be a super user. Okay, and I make dir private. And I change mod to 700 private. So private root can access. Okay, and now I touch private.txt. And private, or even I make dir private inside private. Okay, and now I will make it 400 or 700. Okay, now let's check what happens. So from pathlib import path private / private is there. It is a directory, but there's a permission error. Okay. That's very interesting. That's very interesting. So we should know that this can happen, right? First, let's do the sibling. If home, whatever, if bin is a symbolic link to /home/user/bin. Which one can be a if downloads is a symbolic link to /mount or media hard drive data, something like that. Okay, so what happens if this is, and we change and we check downloads, then this is true. And then the answer, the explanation, is this one here. Is that it returns true both, or a symbolic link pointing to a directory. So we have these things here. So is there. Another question is, what about permission denied, right? So pathlib is dir permission denied. Okay. Let's do a more logical thing, given that we know that it's private. So root is there? Yes. But root blah is there? We don't know. We cannot enter this. What is the output of the following command? So the question is, as always, from pathlib import path, and then we say path /root/downloads dot is dir. And the output is permission denied. Let's add some. Of course, this is already telling us that we're going to have an error, right? If we have all of these spaces. But anyway, permission denied, root blah. So basically, path.isDir will raise a permission denied exception if it cannot access if it doesn't have permissions. Well, permission denied already says this. Permissions to access the given path. Okay. So this is very similar to isFile, right? And now let's try something different today. Should we or should not we? So everybody, when I was starting this project, everybody was telling me, you should use ChatGPT, right? You should use GPT to create all of these cards. And I think that makes sense. But the problem is that what will make Python cards successful or not successful is going to be the cards. So space repetition exists and has existed for many years, and learning Python has existed for many years. But to learn Python through space repetition, you need the right set of cards, right? So for me, it's very important that I create all the cards manually, that I go through them manually, because I think that's where you see like the spirit of like what is important and what is not so important and so on. I think that's cool. But now I was thinking, yeah, so isDir has these cards, and isFile is exactly the same, right? isFile, we can create the same cards. The symlink applies in the same way. The permission denied applies in the same way, and so on. So could we use ChatGPT or GPT-4 to create the same kind of file of cards? Probably yes. But for now, I'm not going to do it. Because then we need to glob, iter, dir, walk, and these are all different things. So let's stick to all of this. So isFile, how you say it points to a file, right? That's what a regular file to a regular file. So what is a good file that we could use? Well, setup.py isFile. isFile returns true if a path points to a file or to a symbolic link pointing to a file. Okay, so isFile, we got it. Then what if it doesn't exist? What is the output of the following command if setup.py does not exist? So this question, the logic behind this question is that it could raise an exception, right? You might think that is file. If the file doesn't exist, raises an exception. So is file returns false if the path does not exist. Okay. Then symlink. So what is the output of the following command? If downloads, not downloads, but now, well, you could say typical examples. So etc nginx sites enabled slash dot, is it dot d? Let me check this real quick. etc nginx sites. I don't have it installed. Nginx sites enabled. This is a typical way of okay, whatever. Close. Sites available, sites enabled. So this is a typical way of enabling and disabling files, websites in Nginx. It's sites enabled slash whatever, Python.cards, for example, is a symbolic link to etc slash nginx slash sites available slash Python.cards. So, or let's say Python.cards.conf and Python.cards.conf. So, if it is a symbolic link from this guy to this guy, the question is it a file or is it not? And the answer is yes. So is file returns true if the path points to a directory, to a symbolic link pointing to to a file, or to a symbolic link pointing to a file. Okay. And finally, what? Permission denied. I did not copy this. Let's copy this. Okay. So what is the output of the following command? Root secrets.txt is file. Root secrets.txt. So we cannot steal the root secrets, right? Or let's say dot ssh/idrsa. That's what we want to take. We want to steal the SSH identity of root. But well, we don't want even to steal. We just want to check if it's a file, right? But we don't have. Let me see if I have this permission. /.ssh idrsa, of course, permission denied. Even if this place doesn't exist, right? I mean, the problem is that. So this is implicit. Let me make it clear. I don't have access to root, so that's a key point. If we have the following permissions on /root, that's a key point, right? So we wait, bash, right? So if we l or shell, if we ls minus l root, then we have some stuff here, some stuff here, and then we have the root thing. Let me make me smaller so I don't cover all of the screen. So it's 20 November, whatever. Root. I don't know. I think let's not even go into this thing. Okay. So we got is file and without the help of ChatGPT. So if there's some competitor out there writing Python cards with ChatGPT, they're going to outcompete us, and we're going to be out of business. Okay, so what else? So make directory has some stuff, right? Parents exists. Okay. Let me do a quick one now. Glob is interesting. Open is interesting. Walk is interesting. Rename. Read text. Read text is very. Oh, the optional parameters have the same meaning as in open. That's interesting. What optional parameters? It doesn't show here that there are any optional parameters as far as I can tell. Let's go to the implementation. So def read text self encoding errors. Oh, wait. Yeah. The optional parameters are this one here. Encoding and errors, these are optional parameters, obviously. And they have the same meaning as in open because they are forwarded to open. It's interesting that like the implementation of this thing, read bytes and read text, is very simple. We could even there's one type of cards that I haven't used so far that I think will be more common in other decks that are not so much about memorizing stuff, like this one, which will be how can you simplify this code, right? So, wait. 1, 2, 3, 4. So the question is, can you implement this code in a single line using pathlib? And the answer is yes. And it is, well, instead of return, let's say content equals this. And the answer is let's add more stuff. Okay, so let's add more stuff. So let's do from pathlib import path, and then we'll say self. Okay, so we say f equals file.bind binary, for example, and then here we say f.open as f, well, as f. So let's say object.bin. So let's call this object. Oh, we cannot create it. Name it object. Let's call this data. Data we could do data.open, or we could do open data, right? So let's make this blood.txt. So instead of using, so if we say with open data mode equals rb as f, content equals f.read. Okay. So yeah, instead of using the open, can you simplify this code? Yes, you can. So from pathlib import path, and then you say content. So okay, instead of data, let's make this path, right? Path. And data is this. So we would make data equals, okay, this needs to be a path. So this is path data.bin .read bytes. Okay. And now, so now you have read this file in binary with a single line. It's just nice. It's convenient. It's one line. It's easy. You don't need to remember the RB, though it's very good to remember that. But 2 or 3 of the more common things that you do, read bytes, read text, write bytes, and write text, they are very easily accessible through this function. Oh, let's have a number here. So this is a name, an ID, pathlib, read bytes. And we're going to create also read text. Read bytes, we could, it just doesn't have any other argument or anything. There's nothing more to it. Read text has the encoding and the error, so we'll have to create a couple more cards for that. Okay, for the following cards, I want to try something new. That is, I've been thinking that our process for creating cards is a bit slow, right? I wouldn't be a computer programmer, coder, engineer, whatever you want to call it, if I wasn't a bit lazy, right? I want to automate stuff. So before we mentioned AI, and surely we're going to give a try to AI, but probably not today. What I want to do now is split the process of creating a card into 2 steps. So first I'm going to write a sentence into what the card is. And second, we can create the card. What do I mean with this? Let's take iterdir, for example. So what we could do is, for iterdir, instead of creating these IDs in which it's just pathlib is file permission denied, which is not understandable, I'm going to create IDs, or I'm going to create titles that actually have meaning, right? So from this entry in the documentation, the pathlib.iterdir, probably we're going to create more than one card for the different concepts that we are going to find. So for example, when the path points to a directory, yield path objects to the directory contents, okay? The children are yielded in arbitrary order, and the special entries dot and dot dot are not included. If a file is removed from or added to the directory after creating the iterator, whether a path object for that file be included is unspecified. Okay, so we don't know what will happen if we remove a file well after we created the iterator. So it doesn't say what happens if this is a directory. So let's, how do you list? That's IPython. So let's list data, for example, right? So if we run Python and we from pathlib import path and we create this path data. So dot iterdir. Okay, iterdir is a generator. So if we create a list of this thing, we get these paths. So, however, if we try to iterdir test.sh, not a directory error. That's interesting. I didn't know. What is a not a directory error? Okay, it's an exception, a built-in exception. Okay, raised when a directory operation such as listdir is requested on something which is not a directory. Okay, so that's cool. So let's try to create all of this, the titles, the summary of this card. So we will create a sentence that summarizes each card. So for example, that is a snippet of knowledge, right? That is, when you do path.iterdir on a file, on a path that doesn't point to a directory, not a directory error exception is raised. Now we need to rephrase this thing. We need to make it short. So for example, running or path.iterdir raises a not a directory error exception if run if we have this path. I guess this is the right syntax, but this is the class, but we could say path dot if run, or if the path doesn't point to a directory. Is that even shorter than the than what we had before? I like it better because you don't have this when you do. That when you do looks very bad. So iterdir raises a not a directory error exception. Probably exception is a redundant thing. It raises a not a directory error if the path doesn't point to a directory. Okay, I like it. So that is one snippet of knowledge that we have from here. In fact, it doesn't say. Well, it says here, right? Then, so path.iterdir returns a generator. That's interesting too. And then path.iterdir returns a generator, sorry, listing or yielding, right, all the directory contents. It's a generator, so we could say have two cards saying whether it's a generator or not, but well, iterdir already points that this is a generator, right? It doesn't say list dir, for example. So the children are yielded in arbitrary order. So yields children in arbitrary order. That's interesting to know. These specialities are not included. I don't think we need to create a card for that. I mean, I don't know. I don't think it's pretty obvious it should not be included. So if a file is removed from and added, so removing or adding a file to a directory after creating a path.itterdir generator. So it's unspecified means that we don't know. We don't know what will happen, right? So so how do we state this fact, right? Removing or adding a file to the directory after creating a generator, I mean, is unspecified, but it's not specified. It's specified whether the generator will include this file. A file added if a file is removed or added to a directory after creating a path generator, let's rephrase this like this. It is unspecified whether a file that is removed or added to a directory after creating a generator will be listed, will be yielded by the generator. Okay, so that's unspecified. So here we have summarized all of this logic here. It's interesting that it returns a POSIX path, not a path. So what if we take the first one and we say is file? Is FIFO? Well, I guess there are some conversions here. I don't type of. This is JavaScript, right? Type. Type of itterdir. Oh, I forgot the list. It's a POSIX path. I don't know. Never mind. Okay, so all of the logic inside itterdir, the children are yielded in arbitrary order. Okay, the order we already said. So everything is, let's add maybe 3, 4. I don't like that it's very, very big, right? I think I'm going to make it a list. Or maybe okay. 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 So this is regarding the itterdir. I'm pretty happy with this because I'm pretty sure I've been faster in creating this list of titles than if I had been creating all of the cards. And also it gives a better overview of what we're doing, right? We have here this raises this returns generator, it returns in any order, it isn't specified whether a file that is removed added generator. So we basically we parsed all of this information, right? So now we can go for the next one, and I think I'm going to continue with this logic, and then we can create from each of these titles, we can create a card. I also want to, so before I said that we are not going to use AI, right? I think we're going to use AI. I think we're going to try to, but I like these steps better because, so I don't have much experience using like large language models. And so, I mean, I've used large language models, I've used Copilot, I've used some ChatGPT and so on, but I don't have like a huge experience, but I've been following the news, right? So one thing what worries me is that if you start creating generated content from LLMs, you can create a bunch of crap, a bunch of spam, a lot of code, signal to noise is bad, and that I don't definitely want. I will be studying from these cards. I don't want to, and people will be studying from these cards. I don't want this to be just a bunch of random facts with no, prioritization of what is important, what isn't important, why, if this is the best way to state things, and so on. So one problem is that, but separating the act of creating these cards into two steps. So first we create like the facts that you will learn, and second you create the card, which can have an example or can have some code that you need to know the output, or prompts you to ask, so what is the function to list directories, and it's iter_dir, and so on. Now we have like a curation step. So ideally we could create some LLM prompt, so GPT-4 or whatever prompt, or GPT 3.5 prompt, to parse this kind of documentation, generate the list of facts from this documentation. Then we would curate it, so we could add more, remove, and whatever. And then we can do a second step in which we translate each of these titles into a card. I think by dividing this process, we have a much better overview. It's much easier to review a list of 10 or 4 or 5 or 2 items that describe a single fact than to try to assess that if ChatGPT generates 20 cards and then you need to go through the details and so on. So I think this is an optimization in our process to create these titles, and these titles I think they will be whenever we have a view in the app to review all the cards and so on, which we need to do. This will be a helpful way to have the title of each card, which is understandable, and I will also go and translate all of this. Pathlib when? What does this mean when? The fact here is not when. The fact is we could say it. Pathlib, or the pathlib module was added in Python 3.4 on year 2014. So that is the fact. That is the fact that we are teaching. So it's not pathlib when. I want to get rid of this ID. So we could make it even shorter. Pathlib was added. I think the pathlib module is fine. So I think we are going to edit all of these cards some other time probably to have this kind of explanation. Or here we could say, so class here, what is the hidden class? And the one that I hid is here. So we could say pure path is the top class in this class hierarchy, that all of these other path subclasses, classes subclass. Okay, so we did iter_dir. Let's go for the next one, which is glob. Path.glob. So this is a good one. Okay, this is a good one, and for sure we're going to make a pretty long list. You can already see that this is a long explanation. Let's see. For example, we can get rid of the easy things first. So case sensitive. What does the case sensitive do? Well, let's read all the text first. So glob the given relative pattern in the directory represented by this path, yielding all matching files of any kind. So before we already tried to iterdir on test.sh. Let's try to glob everything. Okay. Glob doesn't fail. It gives an unacceptable pattern. So, hello. Almost everything. Almost everything. But if we do this, or we do, I don't know, this, value error. What if we do this? Value error. So path.glob raises a value error if the pattern is incorrect. Incorrect. So for example, empty or 3 asterisks, right? Okay. Okay. So that's one. Also, interestingly, it works if it's a it works on a file. So I think path.glob that what do you call this? Is it an empty generator? Is it a generator that doesn't yield anything? Let's say doesn't yield any result if run on a path pointing to a file. Okay. So path.glob this sorted. Okay, patterns are the same as for fn match with the addition of, okay, so path.glob uses fn match, which is this library that implements this kind of wildcards, question mark, and all of this. So uses fn match to interpret glob patterns to match glob patterns. Path.glob plus this thing here. This means this directory and all subdirectories recursively interprets pattern as this directory and all subdirectories recursively. Okay, so that's something else we have. Then, so recursive globbing. What happens if you glob, right? So from here, you glob this thing here. Non-relative patterns are not supported. this is listing everything, my friend. For x in here, print x. Oh my god, there's many things here. So anyway, glob slash dot py. Okay. Okay, non-relative patterns are not supported. Path.glob on slash hello. Yields or whatever. Raises a not implemented error because non-relative patterns are not supported. It's interesting if that this is a not implemented error. It could be a value error, right? You could expect that the problem is that this is not. So of course you could do this thing that you're trying to do here, like from here you're trying to do hello. Doesn't make any sense. You could glob hello. But anyway, so I somehow would think that this is a value error, not a not implemented error. Okay, so by default, or when the case-sensitive keyword only argument is set to none, this method matches paths using platform-specific casing rules. Typically, case-sensitive for POSIX and case-insensitive on Windows. Sets case-sensitive to true or false to override this behavior. So, path.glob follows the case sensitivity, the default case sensitivity behavior in its platform. POSIX equals case sensitive, Windows equals case insensitive. Let's for POSIX, case insensitive for Windows. So, and then you can override the case sensitivity behavior of path.glob with the case sensitive argument. Okay. So return only directories if pattern ends with a pathname component separator. Okay, that's also interesting. So you can glob in the current directory anything slash or anything slash. Okay. You can make path.glob return only directories by having slash or having obsep as the last by having the pattern by ending the pattern with offset. New in Python 3.11. Okay. Or changed. Changed in 3.11. Let's see one thing. Match. Okay. Here we are. Okay, so we have added 1, 2, 3, 4, 5, 6, 7, 8 cards for glob, and I'm not sure we have covered everything yet. We have covered the case sensitive thing. We have covered the return only directories. Rises auditing event with argument. What is an auditing event? What is this? I have no clue what this is. Note, using this pattern in large directory trees may consume an inordinate amount of time. Okay. One of them is okay. One day I will understand this. For now I don't. So glob the given relative pattern in the directory represented by this path, yielding to all matching files of any kind. So we know what this does, but I mean, we have explained all of these subtle functionality things, but we haven't said what we are really doing. So path.glob globs the given relative pattern in the directory represented by the path, yielding all matching files of any kind. So we are basically paraphrasing the documentation here. In no order, I guess. So here, if we list this, it's fixtures, accounts, ideas. So it's in an arbitrary order, right? Path.glob yields matches in arbitrary order. Okay. Let's save the copy. Let's save a copy of what I'm doing. Added a bunch of pathlib cards. Let's send this to GitHub. Wait. Okay. Okay, so let's open Python. It's always helpful. So I think we have covered glob. I think we have covered glob. By default, or when the case sensitive keyword, blah, blah, blah. Okay. Let's go to walk. Walk is very similar to glob. Not exactly. So generate the file names in a directory tree by walking the tree either top down or bottom up. So for its directory, in the directory tree rooted at self, including self at excluding dot and dot dot, the method yields a 3-tuple of dir path, dir names, file names. Dir path is a path for the, let's, instead of reading, I mean, we'll read this, but let's, from pathlib import path dot work. This is a generator, right? So for x in dot work, print x. So it yields this kind of tuples, right? Blah, 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 blah. Yields a 3 tuple of dir path, dir names, file names. So dir path, directory, dir names, and file names. I guess these are basically directories and files. Dir path is a path to the directory currently being worked. Dir names is a list of strings for the names of subdirectories in dir path. The file names is a list of strings for the names of the directory, blah, blah, blah. To get a full path to the directory in dir path, do dir path /name, okay. Whether or not the lists are sorted is file system dependent. If the optional argument top-down is true, which is the default, the triple of a directory is generated before the triples of any of its subdirectories. Directories are worked top-down. If top-down is false, the triple of a directory is generated after the triples of all of its subdirectories are worked bottom-up. No matter the value of top-down, the list of subdirectories is retrieved before the triples for the directory insertions are worked. So when top-down is true, the caller can modify the dir names list in place. Will only recurse into the subdirectories whose names remain in dir names. This can be used to prune the search or to impose a specific order of visiting, or even to inform path.work about directories the caller creates or renames before it resumes path.work again. Modifying dir names when top-down is false has no effect on the behavior of path.work since the directories or dir names have already been generated by the time dir names is yielded to the caller. Okay, this we need to explain. By default, errors from os.scandir are ignored. If the optional argument on error is specified, it should be a callable. It will be called with one argument an os error instance. The callable can handle the file error, blah, blah, blah. Note that the file name is available as the file name attribute of the exception object. By default, path.work does not follow symbolic links and instead adds them to the file names list. Set follow symlinks to true to resolve symlinks. Okay. Be aware that setting follow symlinks to true can lead to infinite recursion if a link points to a parent directory of itself. Path.work does not keep track of the directories it has already visited. Note: path.work assumes the directories it works are not modified during execution. For example, if a directory from dir names has been replaced with a symlink and follow symlinks is false, we'll still try to descend into it. To prevent such behavior, remove directories from dir names as appropriate. Okay, like this is some heavy stuff. And unlike os.work, path.work lists symlinks to directories in file names if follow symlinks is false, which is also an interesting difference. This example displays the number of bytes used by all files in its directory while ignoring PyCache directories. Okay, so here, let's see how this example works. So, root directories files in path.work. So you print the root, consumes all you do stat and you get the size of each file in files, bytes in files. If this is here, remove from dir's directories, and this because it's top down, remove these things from here and then it continues to walk, I think. This next example is a simple implementation of shutil rmtree, walking the tree bottom up. It's essential as rmdir doesn't allow deleting a directory before it is empty. Okay, so we unlink and remove directory for every single object. Okay. Okay, cool. And what is new in version 3.12? Is the whole work thing is new in version 3.12? Python 3.12 release notes. Walk. Okay. Stanislav Zmiev. Thank you very much. Thank you very much. So let's see how this is implemented. Oh, here's the PR. No commits. Where are the commits? Let's see what this guy says. Pathlib is great. Every time I have to parse a bunch of files, I have to use OS walk and join paths by hand. That's not a lot of code, but I feel the pathlib should have a higher level abstraction to do all of this. Yeah. Okay, here's the PR, I think. Files changed 5. Here we will see the implementation. Here is the documentation that we've been reading. Walk. Audit, self on error, follow some links. Okay, so scan dir of as error, dir names, file names for entry. If try is dir, entry is dir. Top down yield. If not top down yield. This is very. It's interesting, right? Because this is a recursive call, right? So I mean, the implementation just makes everything very clear. So walk has this top down option. If it's top down, we yield and then we recurse. If it's not top down, we first recurse on all the dirs and then we yield, right? And then the other thing is that we allow to modify the dir names, right? So if the dir names that are yielded are modified, we remove an element from this list, then it will not be worked afterwards. So, well, this is a nice feature. I guess not many people know about it. I didn't know about this because this is from Python 3.12, which came out pretty recently. But it's a nice addition. Also, we saw in the issue that introduced it that some people complained, right, about how using OS walk wasn't exactly useful because you need to join the paths and so on. So, okay, let's look at os.walk. We're going to add a bunch of cards, but I think we have a good understanding of what path.walk does. So, path.walk generate the file names in a directory tree by walking the tree either top down or bottom up. But not the file names. It's the file names and the directory names and the directory paths. So walks recursively visits a directory tree and yields its files and directories. And yields the content of each directory. Okay. Path.walk yields a triple or a 3 tuple dir path, dir names, file names, for each directory. Path.walk by default yields directories or visits directories top down. That is yielding a directory before visiting its children. Path.walk allows you to remove directories from dir names while to prevent visiting them when top down, when following the top down approach. Pathwalk yields the children follows a bottom-up reads the children of a directory before the directory when not prints. Yields all the children of the directory before that directory when top down equals false. So when top down is true, a triple of the directories generated before the triples of any of the directories. If top down is false, the triple, no matter what the value, or the list of directories is retrieved before the triples for the directory and its subdirectories are worked. Okay, yeah, that I understand. When top down is true, the caller can modify the dir names list in place. Okay. And path.walk will only recurse to settings whose names remain in dir names. This can be used to prune the search or to impose specific order or visiting, or even to inform. Okay, so even the order sorting or modifying the order of dir names in path.walk allows to control the visiting order on the children directories. Okay, that's interesting. So you can delete, but you can also sort them and so on. Modifying dir names when the top down is false has no effect on the behavior. So, since the directories in dir names have already been generated by the time dir names is yielded to the caller. Yeah, so it's pretty obvious. When path.walk top down equals false, modifying the dir names has no effect. Okay. By default, errors from OS scanner are ignored. If the optional argument on error is specified, it should be a callable. It will be called with an. So, what is a scanner? So let's see. Errors on path.walk are, but not all errors, right? Errors from OS scanner. Okay. Are ignored, but can be handled by with the argument parameter on error, which must be a callable that will get an os error instance as an argument. Okay, this might be split into two sentences or two cards, but let's see later. So path.walk doesn't follow symlinks or symbolic links by default. Path.walk can follow symbolic links by using, well, by setting, by calling with follow symbolics equals true. Path.walk symbolic links using this thing here may lead to an infinite loop if there are links to upper directories. And then when follow symlinks equals false, path.walk will list symbolic links as files, even if they point to a directory. Okay. So this is path.walk. It seems my cards are even longer than the documentation, but that's not true. So these are the path dot. Oh, can we remove this? Yeah, that's nice. Let's make this a little bit bigger. So, and here we can. Okay. Walk, path.walk. Okay. So this is cool. Walk was long. Walk was long. We have also I listed this as important, but then we can. So let's do another pause, right? And let's talk a little bit about these cards. So if you want to learn Python in depth, there are many things that you should know, right? I think Guido van Rossum, the creator of Python, doesn't know everything. Probably doesn't know all the details of this. The good thing is that many of these facts, or most of these facts, are not random. They are not like a one-off thing. They follow a convention. So you will see many of these we have seen already follow symlinks to be a parameter in many functions. So there are some patterns here. It's not like you need to memorize like completely unrelated things. The other thing is that, of course, the whole knowledge of Python is big. To understand, to fully understand what path.work is doing, you need to know all these facts. And probably we still didn't say like what the exact difference between path.work and os.work. We didn't say that this is different from os.work. Okay, let me put it here. Unlike os.work. So I think we can follow like a Pareto kind of approach to Python, in which if you learn 20, you could learn 20% of the facts that we're listing here in order to know like 80% of what you will really need for Python. Right? So only 20% of this knowledge. So knowing that walk exists, knowing that it returns the dir path, dir names, and file names, and a couple more things that you can do it top down and bottom up, you know more than enough probably to be able to use path.work whenever you need it, right? So, but still, we need to have this comprehensive set of cards. We need to lay out all of the facts before we can make this decision of what constitutes that 20% or what constitutes the remaining 80% that you might want to learn or not, right? So now we're doing this work of getting all the facts collected, creating this whole deck, and then we can decide how we organize it so we don't learn or we spend too much time learning things that are not that important. Okay, let's continue. Okay, let's go. I'm going to start to have dreams about pathlib, I think. Okay, path.make directory. So if you're wondering why this hasn't been done before, like creating these sets of cards for Anki and so on, it's because it's tedious. It takes time, you know? But I enjoy it. So, and hopefully this is the hard work. So now we still have, I mean, the list of things we wanted to do is somehow getting shorter. So whenever we know we have all of this done, then we can iterate and improve. But this is the hard work we're doing now, okay? The hard work that few people have done. I mean, many people know pathlib. Fewer people, I guess, know it in depth. And I'm learning it. Okay, so create a new directory at this given path. If mode is given, it is combined with the process's umask value to determine the file mode and access flags. If the path already exists, file exists error is raised. Okay, now here we need to understand what this umask means, right? Okay, this is, we want it in English. So the determinative mask controls file permissions. So this, I mean, I think I know what this is, but I mean, I know what this is, but we'll have to take that into account. So create a directory. It is combined with the umask to determine the file mode and access flags. If the path already exists, file exists error is raised. If parents is true, the parent directories are created. Okay. If parents is false, a missing parent raises file not found error. If exist OK is false, so the default file exists error. So we have either a problem if it exists or if it doesn't exist, right? And if exist OK is true, then this exception will be ignored, but only if the last path command component is not an existing non-directory file. What does this mean? Okay, I mean, if it's a file, it will fail, right? If it's a file, not directory. Okay. This one is much simpler. The documentation of make directory is very straightforward, and it's also even like a bullet point list. So I think it will be easy to translate this to this list of titles that we're creating. Okay, this creates a directory at the given path. So that's the first thing to note. That is true. What happens if let's talk about the mode, leave it for later. If parents equals true, any missing parents of the directory will be created with the default permissions. If parents equals false, missing parent will raise. Well, I'm talking about path.make there, so path dot dir raises a file file not found error if a parent is missing and parents equals false. So this one raises a file exists error if the file already exists and exist OK equals false, the default, right? Then this one raises a file exists error even if exist OK equals true, if the path already exists and is. So let's try it. Do we have path here? Yeah, so path test.sh. So path test.sh is file, right? This is a file. So if we take dot and we make a directory of test.sh, oh, sorry. Now what am I doing? If we make this directory, file exists. Even if we say exist okay equals true, this is an error, right? If we did this with blah, which already existed, okay, this works even if we do it many times. But here it fails because it's a file. So there is a file system even if exists okay equals true, if the path exists and is a regular file. Okay, so we have more or less explained everything except for the mode. The new directory created by path.makedir will have mode permissions mode combined with the process umask path.makedir mode equals, remember the octal number when we used chmod. So this one here has combines the mode with the umask of the process to determine the mode and access flags. So this, we were talking about the umask. Let's see what this is. This is not determined by Python. This is like the operating system, right? I mean, what this thing does is that if we create this directory, let's create this directory blow, okay, we quit and we ls minus l, basically blow has this, okay, it has the 777, which is not what the rest have by default. Yeah, so probably you need to just set it manually. Anyway, this, when we elaborate on this card, we might want to explain what the umask is, but otherwise, this is enough. Let's remove this tutorial. So, okay, we have added a bunch of cards that are not really cards, but they are titles of cards, right? I think we have covered some of the big ones, right? Like open is easy. Open basically forwards all the arguments to open. So this would be, if you read the documentation, open the file pointed by the path, like the built-in open function does. Path.open opens the file pointed by the path, like the built-in open does. Okay, that's it. No more. We want to explain what open is. We will do it in the built-ins. I have it in the roadmap. So there is this built-ins coming soon, which I want to also cover, in which we explain all the built-ins, what they do. So open was easy. Read text is easy. So let's read text. Path.read text. What does it do? So read text return the decoded contents of a pointed to file as string. Returns the decoded contents of the file, opening and closing the file. Path.read text. It's interesting. This one only handles encoding and errors, nothing else. Can use a custom encoding by using the encoding parameter, and these errors can be handled using errors parameter. So this is the same. The difference is that open has all of the same parameters except for the let me see, path.open. Yeah, it has mode, buffering, encoding, errors, new line. Mode, buffering, encoding, errors, new line. The only thing that doesn't have is this close FD opener. This one only has the encoding and errors. It doesn't have the buffering, new line. Of course, it doesn't have the buffering because it reads everything. Doesn't have a new line because it's a different thing. This is so not reading one by one, line by line. So okay. Okay, let's keep it this way. We might decide if these cards are really necessary or not. Okay, path.rename. Rename this file or directory to the given target and return a new path instance pointing to target. Okay, it's important to know that it returns this thing. On Unix, if target exists and is a file, it will be replaced silently if the user has permission. On Windows, there will be an error. Target can be either a string or another path object. Okay. The target path may be absolute or relative. Relative paths are interpreted related to the current working directory, not the directory of the path object. Okay, that's important. We will have a card probably asking why is this a mistake, but for now we're only just to state the behavior in the title of the card. changing 3.8 added return value. Okay, so renames this file or directory to the given target. Okay. On Unix or Unix related, right? Target will be silently overwritten replaced if the user has permissions. On Windows, this will override target, will silently override target, silently replace target if the user has permissions. On Windows, path.rename target will raise a file exists error if target exists. This returns a new path object pointing to target added in 3.8. Okay. Now, relative path target paths in path.rename target are interpreted relative to the current working directory, not to the directory of the path object. This is very important, of course. You cannot rename. I mean, this is pretty obvious, but you cannot rename. You rename have some file, long file, so this directory, blah, 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 and the file, and you just rename the other file, it will be moved to the current working directory, not to that directory. Okay. I think this is all regarding path.rename. I think path.replace is the same thing, except that it doesn't have this error for Windows, right? It doesn't raise. Rename this file or directory to the given target and return a new path instance pointing to target. If target points to an existing file, it will be unconditionally replaced. So this is exactly the same. So I'm not sure we want to repeat everything. Path.replace target renames this file or directory to the given target, replacing target even if it exists. Something like that. And we can say this thing here returns a new path object pointing to target. Oh. Replace. And this thing, we could make it to here. Okay, So we have replace. The difference between rename and replace is pretty simple. Is that replace, it's only for Windows actually. In Windows, it raises the replace doesn't raise a file exist error. Okay. Okay, absolute. This one is interesting. Okay, so path.absolute. Make the path absolute. So anchor it to the root, right? Without normalization. Return a new path object. A new absolute path object of the path. Path.absolute doesn't normalize the path. Remove this. That means a yes. And this one doesn't resolve symbolic links. And that's absolute, my friends. Let's go for resolve. Path.resolve. Resolve is more interesting. And let's have a quick view into all of these. Resolve or rglob, rmdir, symlink to touch is very simple. Unlink and write text. Okay, resolve. Resolve is very important. Resolve makes the path absolute, resolving any symlinks, symbolic links, and removing components. This is the only. So let's note this here. Path.resolve is the only method that eliminates components from paths. So you want to use that, right? It returns a new path. So path.resolve returns a new path with the resolved returns the absolute path, resolving this and that. Okay, if the path does, okay, it's interesting this strict. If the path doesn't exist and strict is true, file not found error is raised. If strict is false, the path is resolved as far as possible and any reminder is appended without checking whether it exists. If an infinite loop is encountered along the recursion, runtime error is raised. Okay, so path.resolve strict equals false. Resolves the path as far as possible. And any reminder is appended without checking whether the file exists. True raises a file not found error if the path doesn't exist. And this one raises a runtime error if an infinite loop is encountered along the resolution path. Okay, so we got resolve. Now, I'm pretty happy with this approach that we are taking of writing the... If you skipped from before the video, we are... the last days, we have been writing cards like completely from each single card we have been writing here, you see. But now we are starting to just list all the cards we want to have, every single one. And then some other time we will create the actual card. And maybe we will try to use GPT or something to do it. I mean, we'll try it. We don't know if we will. But the good thing is that we're going pretty fast. So this is like the hard thinking part is this one, reading documentation, extracting all the facts. And then we can iterate through this and create the cards and so on, which is more of a mechanic thing or mechanical thing, and it's not so much of thinking. So I think I'm going to leave it here for today. Let me copy these files, cards, copy, added a bunch of cards, push, and now we have this grep. We have 88 cards that we have actually created and 99 items that we have listed. So if we sum that very quickly, we have 150 cards. We still have these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22, I think, like at least we're going to have I mean, for sure we're going to have 200 cards. Probably we're going to have 250 cards. So how much work do we have left? Let's estimate how much work we have left so we can see the end line of this race. We need to take all of these cards and generate these titles. We need to take all of these titles and create the cards. And we need to create the titles and the cards for all of these functions. But I'm doing 1 hour, 1 hour and a half videos, so I think, I don't know, at least one more day to create all of the titles of these cards, one more day, or two, right, to create. So 2 days to create cards and titles, and one more day for all of these things, or 2 more days. Whatever it takes, we're going to do it. Hopefully I will experiment on this ChatGPT stuff of taking these statements and trying to generate a card and see how successful we are. Probably once we have also some examples of titles of cards plus the kind of output, the card, the front and back of the card that we want, we will have something that we can work with. Anyway, I hope you enjoyed this video. It's a very long video. I mean, this is not expected for you to like watch from start to end, but this is more to give you an idea of the work that is getting put into this Python.cards. Also, I have another announcement, if you want to call it that way, which is that yesterday I registered Rust.cards. So if there's a programming language that interests me apart from Python, is Rust. I'm not super experienced with Rust. I've been working with it. Let's make me bigger. I've worked with Rust professionally a little bit. I have much more experience with C++ or with Golang even, or with JavaScript, but Rust interests me. I like it. I think many people are interested, and also it's kind of orthogonal to Python, right? So Python covers the high level stuff and Rust covers the low level stuff. I like its syntax, I like how it is, its ideas behind its principles. So I registered Rust.cards, and let's see. I mean, I'm more of a Python expert than a Rust expert, but I might learn Rust while building Rust.cards. Why not? So stay tuned. I will link that into the Python cards landing page too, and see you some other time. Bye bye.